welcome to our wonderful YouTube channel, Brilliant Tutorials. And I'm here with and my name is Akindele Taiwo. Deborah here is about to share her testimony of using our wonderful YouTube channel.
I usually find physics very difficult, but through Brilliant Tutorials, learning has been very easy for me. I encourage other students out there to join our YouTube channel, Brilliant Tutorials.
Have you heard from our dear Deborah? You guys should like, subscribe, and share our channel with your friends. Bye.
Bye. So now you can show fish.
Okay. Welcome once again to this platform, a platform where we discuss chemistry in and out. It's yet another time with Mr. Brenner, and I welcome you all to this edition of our tutorials. And in today's class, we'll be talking about chemical bonding. We'll be talking about what? Chemical bonding. What is chemical bonding? Chemical bonding is the interaction that exists between atoms, and this interaction that exists between them, it usually involves either transfer of electron or sharing of electron among atoms in order to achieve a more stable state, which could be the ionic form, the molecular form, or the compound form of substances. Now, this is a very simple definition that I just coined out a while ago. And like I normally used to tell my students, whenever you want to look at chemical bonding, you also look at the interaction between humans. And that gives you a better view of what chemical bonding is all about. Now I want to ask, if you look at what we have there, you discover that we are talking of a stable state configuration among the atoms, meaning that a particular atom, as you can see here, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium, as you can see here, are usually not in their most stable forms, especially for those that you can see here, those you can see with charges. You can see some with positive charges, you can see some with negative charges. I don't want to go into this, but these are metals and these are non-metals and these are noble gases. So only those that are having this neutral charge here are said to be what? Stable. Meaning that every other ones here are not in their absolute nature of stability. And this is the reason why atoms want to combine. It is the reason why they want to come together, to achieve a more stable state as ions, molecules, and compounds. So what are the states of stability for the atoms? There are actually two states of stability for the atoms. Number one, state of stability. In atoms. There are two states of stability in atom. One is the octet noble state configuration. This is when an atom or an element has 8 electrons in its outermost shell. So whenever an atom in the periodic table has 8 electrons in its outermost shell, we say that that particular element is stable or has obtained an octet noble state configuration. For instance, you look at the argon, you look at the neon, they have 8 electrons in the outermost shell. Look at neon, for instance. We have 2 electrons here because it has 10 electrons. We look at it this way. 2 and 8, making it 10. So there are 8 electrons in this outermost shell. For every atom that has 8 electrons in its outermost shell, we say that such an atom has obtained an octet noble state configuration, which is a stable state configuration, except for 2 other atoms, which are what? Hydrogen and helium. Hydrogen and helium cannot obtain the stable state configuration by having 8 electrons in the outermost shell. This is because they cannot even have up to 8 electrons. And as such, when they have 2 electrons in the outermost shell, we say that both hydrogen and helium at that state is octed, or at that state is stable. And such stability is called duplet state, or duplet noble state, duplet stable state configuration. So for all the elements in the periodic table, they can achieve octet stable state, all elements, except, let me use red here, except for hydrogen and helium, that can obtain their own stable state configuration by having 2 duplet from 2 stable state configuration. So when helium has 2 electrons in its outermost shell like this, we say it is stable. And that is why helium is in this group of stable elements. You look at helium, is here because it's having 2 electrons in its outermost shell. Neon is here because it's having 8 electrons in its outermost shell. Argon is here because it is also having what? 8 electrons in its outermost shell. So such elements are said to be stable. Thank once again, and till we meet next time in the next video.